Hello. Today I would like to talk about the latest book that I read, which is Black Holes: The Key to Understanding the Universe by Brian Cox and Jeff Forshaw. As you may know, Brian Cox is a physicist. He is also the spokesperson for public engagement in the University of Manchester, if I'm not mistaken. He's basically the person that brings very complex topics of theoretical physics down to the everyday person. He does it by explaining it in very simple terms and very simple words that anyone can understand. And he also does it with a charm. He's very funny with it. He's very nice to listen to him. Of course, he has a great sense of humor, and listening to him is very fun in general. One thing that I want to mention, not only about this book, but Brian Cox as a person, is that he's very humble as a physicist. And I'm sure as a person as well, but as a physicist, he's not afraid to say, I don't know. There are many instances in this book and also in his talks that he says, I don't know the answer to this question. There are some things that I don't know, and he speaks for the entire scientific community. For example, as the book mentions, the relationship or the way to link gravity in the terms of the theory of relativity to quantum mechanics. It's very difficult to link these two ideas together in a way that work together. It's been called the holy grail of modern physics. And he says, well, I don't know the answer, but here are some ideas that could help, that might prove to find the answer in the future. Before I talk about the book, I want to rescue this idea, which is, I think, the most important thing that I learned from this book, and also from other books like The Grand Design by Stephen Hawking, and also El Instinto Científico from Andrés Komberov, which is a Chilean physicist. The idea of accepting ignorance is probably the most important thing that I've taken out from these three books. Saying that I don't know something is the basis upon which every science should be based. I think, and I'm guilty of this as well, many of us have taken a dogmatic view towards science. We take science as the one truth that we all have to accept, and it is an unquestionable truth. Pseudoscience, conspiracy theories, all of these are wrong and they should be laughed at, and basically seeing scientists as the holders of truth, and that it shouldn't be questioned. Basically, we see science as the one correct way to view the universe, almost as an untouchable, which is a very unscientific approach, ironically, to view science. Science should be based on questions, and from these questions creating experiments, and then theories, and hypotheses, and then theories. That is the correct way to do science. But to question something, you first have to admit that you don't know how it works. You don't know the answers. Hence, you're asking questions about it. So the key idea that I want to communicate from this book, I know it's not the main topic from this book, but in general, something really positive that happened to me is to adopt this idea of admitting ignorance in many aspects, and wanted to get more information and to learn about these things. I have to admit, after reading this book, I feel I have more questions than answers. But I also learned how little I knew about the universe as a whole. I think this book, as it says, The Key to Understanding the Universe, was maybe a little of an overstatement. I don't understand the universe, and I probably have more questions now. But the way I thought I understood the universe was very incomplete and very simplistic in its shape. The universe is not as static and not as simple as I thought. I genuinely thought that black holes were not such a big deal before reading this book. I thought, well, we know what's inside. It's just a star that collapsed. So we know what's inside of a black hole is just star stuff. It's the mass of the star collapsed into a single point. Yeah, the gravity may be great, but the gravity is still gravity as we experience it here on Earth. And the mass that's inside, what's inside a black hole, well, is what used to be inside the star. Problem solved. I generally used to think that. And while it's not completely false, the magic of black holes does not come from what's inside. If you want to know what's inside a black hole, well, it's really hard to know, and this book doesn't give you a straightforward answer. And it's also not important, because what's really amazing about black holes is not what's inside, it is what happens to the space-time around it. And it also teaches you a new way to understand gravity. It introduces this very useful tool that is called the Penrose diagrams. I'll probably add a picture if I know how to edit one of those here, which is a way to visualize infinite space and time in two different axes. And they also include, I'll probably add it here, a version to visualize black holes. If you look at a Penrose diagram, it has an infinite time from the bottom to the top, and an infinite space from left to right. Space has been simplified into just one dimension. But if you want to see how a black hole looks like, it has an edge on top. In the time axis, it is finite. It has a limit. It doesn't go into infinity. I know it looks flat and it looks like time has a finite point at the end, but you have to understand this is like a non-Euclidean geometry, so it's like curved. It goes into infinity, but we just see it as a finite point, but it stretches to infinity. However, a black hole has a limit. It has an edge on top. So as sure as you go through time, unless you are going to a relativistic speed, as sure as you go through time at a constant speed, you will hit tomorrow. There's nothing you can do to not eventually be in tomorrow. Tomorrow is a certainty for you. There's nothing you can do. You're moving through this time dimension towards tomorrow. Once you enter a black hole, you'll probably see an event horizon. Once you enter a black hole, you will hit the singularity, which is the edge at the top of the diagram. So you are not moving towards a point in time, you're moving towards a point in space. And the concept of this is that time and space switch roles inside a black hole, and that is what blew my mind. It's only like in the third chapter of the book. There's like 20. This is just the third chapter, but the way you move towards a singularity is analog to the way you move towards tomorrow in normal space-time. A singularity is not a point in space, it's a moment in time. And once you cross the event horizon, there's nothing you can do but move towards it. That is incredible. There's also a lot of small details, like for example, if you ever encounter yourself falling towards a singularity, trying to reach it faster or trying to escape from it, first of all, you're not going to escape, and actually trying to move with a rocket or something away from the singularity will only make you reach it faster, because your own space, your own time will move faster towards that point in time. So if you're ever falling towards a singularity, just let yourself fall. There's a lot of information that I'll skip about the contents of this book. If you really want to know, you should probably read it yourself. That was just a nice way to see. Also, this diagram that I showed you is just for a non-spinning black hole, which is called a Schwarzschild black hole. It's just a static, probably non-existent black hole. It's a simplified version. A real black hole is more like this, which is spinning black holes, which are called Kerr black holes. These are much more complex. They have two mathematical events horizons, and they open up a whole kind of world of possibilities. For example, a new region of space-time that we don't yet understand, the possibility of negative energy, and a way to harvest this energy by throwing stuff into a black hole and getting more energy out of the thing that fell. Well, this also opened the possibility of which is called a Care Wonderland. Call it a multiverse if you want. I'm still on the edge about the theory of multiverse. This book also goes deep into the information paradox, what Hawking probably got wrong, and the question that plagued scientists for many decades is if black holes destroy information, which is a no-no. It shouldn't happen. Short answer is that they probably don't, and the more we are looking into quantum computing, the more we understand that the way nature deals with information inside black holes, which is a nice way to see it. Like, the more advanced we are with our own engineering, we realize that, hey, nature did this by itself a long time ago to solve the black hole problem, information problem. The book is very long. It has a lot of information. I'm going to be honest, I did not understand much of the last few chapters, but I definitely suggest you pick it up. It's the first few chapters are for everyone to understand. I'm probably too dumb to understand the last few chapters about quantum computing. I tried my best. I read it a few times. I more or less got the grip of it. But if you're going to get it, definitely get it on a physical copy. I do not recommend the Kindle version because it has a lot of diagrams and a lot of pictures that depend on color. And it's also not very convenient trying to draw a few pages back in the Kindle and trying to guess which shade of gray is actually the pink or the blue he's talking about. So definitely pick it up, but try to get the physical version. The Kindle is not that great for this purpose. So yeah, great book. Brian Cox, amazing author as always, and yeah, I really liked it.